We do not taste with our mouths first. We taste with our eyes and our brains. This chart maps the brain's prediction engine. A visual signal travels to the brain, generating a predicted flavor profile before food hits the tongue. Because this machinery is efficient, the loop closes without friction. The mouth's raw sensations match initial visual expectations. This matching process allows the brain to transition dining into a passive autopilot experience. If you see a steak and taste a steak, the brain has successfully confirmed its own prediction. In this routine, the brain doesn't need to devote extra resources to processing the experience. It simply checks a box and moves on. Modern food design attempts to disrupt this efficiency, looking for ways to stall the prediction engine. Chef Grant Achatz reached a turning point when he was diagnosed with stage 4 tongue cancer, a disease that temporarily cost him his ability to taste. With his palate offline, he turned his attention to manipulating the other 4 senses to create an experience that didn't rely on chemical taste alone. He developed a philosophy that food should challenge the diner, providing a physical or visual obstacle that forces them out of their baseline routine. His experience established a new blueprint for culinary design. To make a moment memorable, you have to bypass the associations the diner already has. Designers achieve this bypass through a series of specific hacks, starting with the visual. Achatz serves perfectly clear, bite-sized cubes containing the concentrated flavor of a traditional root beer float. The eyes signal the presence of water, but the palate registers rich, carbonated syrup and cream. This animation illustrates cognitive dissonance. 2 conflicting datasets, visual and tactile, clash, creating a zone of high-friction data. While the brain tries to avoid this friction, curiosity encourages it to build a new pathway to process the information. This process is pushed to its limit with edible, helium-filled sugar balloons that float away from the plate while tasting like apples. These visual contradictions force the brain to discard its automated predictions and focus entirely on the raw sensation of the meal. The design also extends to the physical structure of the ingredients through the application of physics. Using rapid microwave dehydration, chefs can puff everyday ingredients, changing their structural density and mouthfeel. Scientists at the EHL Robot Project took this concept even further, replacing a machine's beeswax structural casing with chocolate. When they added a sharp acidity to that structural chocolate, they created a flavor profile that doesn't exist in traditional confectionery. This is a formal academic system. It integrates the laws of physics with service design to alter the way we perceive food. Beyond the plate, the restaurant environment itself is used as a design variable. Michelin inspectors have noted how chefs use the scent of Binchotan charcoal or the intimacy of counter service to influence the diner's state of mind. This combination of molecular physics and environmental cues creates an experience where every sensory input is a deliberate choice by the designer. When our learned visual associations are stripped away, the brain's autopilot stops. It has to process the raw data of the meal as it happens. Whether it's an acidic battery or a floating balloon, these designs use science to produce a specific emotional reaction. This methodology represents a shift away from the traditional reliance on rare or expensive ingredients to define high-end dining. These experiences capitalize on the moments when our predictions fail, leaving only the immediate sensation of the meal.